Okay, so hello and welcome back. So in this video we want to talk about, in the previous video we were talking about how to find the mean deviation about mean and median. So we were talking about the mean deviation about mean and deviant, and not deviant but median. So what we said over there was that if you have, for example, a set of observations, for example, you have 2, 7, 8, 7, 6, 1, 7, 8, 7, 6, 1, 7, 9, 10, 5, 2, 7, 8, 7, 6, 1, 7, 9, 10, 5, so suppose you have these observations, and the number of these observations is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. So you can say that n is equal to 20. Now if the number is 20, now the mean deviation about mean and about median, what that means is that if I take the minimum of these observations is basically 1. The maximum of these observations is, these are all, well, 2 digits number. We have a 10 over here as well, so we have a 10 over here as well, so the minimum is 1, the maximum is 10. So if I have a number line over here going from, for example, 1 to 10, this is 1 and this is 10. So the average of these two numbers is going to be somewhere about here, which is 5.5. This is the mean or the average. And your data is scattered from here all the way up to here. These are the data points that you have. Now what happens is that now you can of course calculate your mean, and we wanted to basically find a way to, of course, the mean or the average of the data is not a good representation of how the data is scattered. You could have a bunch of basic observations, in which case, for example, the mean is 5.5, and now you can see that the range of the data goes from 1 to 10, and then you can have another separate set of observations that goes from, for example, 5 to 6, and that second set of observations could have the exact same meaning, for example, 5.5. so while I could have basically this measure of central tendency about the two data, meaning that I know that in both cases the data is the mean of the data is 5.5, the central tendency of the data is 5.5, or the mean of the data is 5.5. But if this number was the only number that I had about this data, this wouldn't tell me about how the data is scattered or dispersed around this mean, or basically what is my minimum, what is my maximum, and what's going on with my data. So then we found a way to solve this problem. We said that we are going to find basically the mean of the data, which is basically in this case, for example, 5.5. And once I have the mean of the data, I'm going to take each of these observations and calculate the distance of this observation from this observation. So for example, this observation would be right over here, which is basically 2. So now 2 minus, for example, 5.5, if I take the absolute value of that, is basically 3.5. So that means that the distance of this observation from this observation is 3.5 units. And then what I can do, okay, so what I do now is that I take, for example, each and every one of these observations. So for example, 2, and calculate the distance of this observation from this mean of the whole data, and take the absolute value of that to get the distance of that observation from the mean of all of the observations. And then I do the same thing for 7, do the same thing for 8, and so on and so forth. And now then then I will get a bunch of numbers over here. For example, this would be, for example, 2.5 units away from this. This would be 2.5 units. I'm sorry, this would be 8, 5.5, for example, 2.5, no, 6. So these basically, the difference between 8 and 5.5 is basically 8 would be somewhere over here. So 6 and 2.5, 6 and 2.5. Anyway, you would get a bunch of numbers over here. And then to get a sense of, basically you want to get a number representative of how your data is basically scattered all over the place, right? So in order to get that number, we get all of these numbers and then find the mean of all of those numbers, and then that would give you, for example, some number which is at some distance from this mean, and that gives you some idea of how basically all of the observations have basically were behaving in the case of that set of observations. And that number, which is basically the mean of all of these numbers, is called the mean deviation about mean, for example. That is called the mean deviation about mean. And the mean in this context, in this book, in this chapter, has been called x bar here. So we write it as the mean deviation about mean. On the other hand, if you do the same process, but instead of calculating the mean deviation about mean, if you calculate it about median, meaning instead of calculating the mean of all of your observations, calculate the median of your observation. And then do the same process for that median, meaning that finding the distance of all of these observations from that median and then taking the mean of all of those numbers, then you would have the mean deviation about median, which is represented by m. And we said that basically the mean deviation about, for example, the mean deviation about for example about the mean of all of these numbers, so the mean deviation about the mean is the same thing as basically you have to find all of the distances between you have to find all the distances between the between some x bar and some other observation, some x bar and some other observation. So you can call that observation, for example, x of I. So you can write it as basically x of I minus x bar. And since we wanted to take the absolute value of that, so we take the absolute value of that, and then we have to add all of those together. So I write the sigma of all of these, all of such points. And of course, then you have to divide that by the by the number of the observations, because you want to find the mean of those things. So divide by n, which you can write as 1 divided by n times sigma. Of course, here basically I goes from 1 to n, of course, that you already know. And then this you can write as 1 divided by n times sigma of x of I minus x bar when I goes from 1 to n, for example. So that's the mean deviation about the mean. This is the mean deviation about the mean. And then you can also have the mean deviation about the median, which would be basically simply the mean deviation about the median. M denotes median here. So here basically x bar is the mean. And the mean deviation about the median, by the same logic, is 1 divided by n times sigma of x of I minus the median. X of I minus the median, take the absolute value of that as I goes from 1 to n, and where basically m is equal to the median. Okay, so that's how you calculate, for example, the mean deviation about the median. So that's basically what we did in the previous 1 or 2 videos. Okay, so now as an example, let's do example number 2, which I have a set of observations, which is basically, for example, you have 12, you have 3, you have 18, 17, 4, 9, 18, 17, 4, 9, you have 17, 19, 20, 15, 8, 17, 2, 3, 15, 8, 17, 2, 3, 8, 17, 2, 2, 3, and 16, 11, 3, 0, 5. 16, 11, 3, 1, 0, 5. So you have this set of observations, and the number of these observations is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, and 20. N is equal to 20. Now if you have these observations and you want to find the mean deviation about the mean deviation about the mean, which is basically x bar. So what you need to do is that we said that the mean deviation about the mean is basically 1 over n sigma x of I minus the absolute value of x of I minus x bar over well, I have already written over n as I goes from 1 to n. Okay, as I goes from 1 to n. So that means that I have to calculate x bar over here. And so if I want to calculate x bar over here, you know that x bar is equal to 1 over n sigma x sub I. That means that you add all of these numbers together and then you divide it by the number of those numbers, which is 20. So if I do so, what I will get is basically 12 plus 3 plus 18 plus 17 plus 4 plus 9 plus 17 plus 19 plus 35 plus 8 plus 17 plus 5 plus 16 plus 11 plus 4 plus 5 is equal to 9. So that's 200. 200 divided by 20 is equal to that's equal to 1 divided by n, which is 1 divided by 20 times 200. So divide by 10, you will get a 20 divided by 10, you will get a 2, and 20 divided by 2 is equal to 10. That means that your x bar is equal to 10. So then you can write this as 1 over 20 over sigma of x sub I minus x bar. X sub I minus x bar. So sigma basically x sub I minus x bar, the absolute value of that as I goes from 1 to n. And this is a tedious thing to do, of course. So here my x bar is equal to 10, right? Now this is a tedious thing to do because you have to calculate 1 divided by 20, and then you have to basically write the absolute times the absolute value of, for example, 12 minus 10, the absolute value of that, plus, for example, 3 minus the absolute value of 3 minus 10, plus the absolute value of 18 minus 10, plus the absolute value of, for example, 17 minus 10, plus the absolute value of 4 minus 10, plus the absolute value of, for example, 9 minus 10. I think we will have some formula for this. Plus the absolute value of 17 minus 10, plus the absolute value of, so we had 12, 3, 18, 17, 4 and 9, and then 17, and then we have 19 minus 10, plus the absolute value of 20 minus 10, plus the absolute value of 15 minus 10, plus the absolute value of 8 minus 10, plus the absolute value of 8 minus 10, 15, 8, 17 minus 10, plus the absolute value of 2 minus 10, plus the absolute value of 3 minus 10, plus the absolute value of 16 minus 10, plus the absolute value of 11 minus 10, plus the absolute value of 3 minus 10, plus the absolute value of 1 minus 10, plus the absolute value of 0 minus 10, plus the absolute value of 5 minus 10, and you have to calculate all of this and then divide it by 20. which is the same thing as 1 divided by 20 times 12 minus 7 is equal to 2. 2 plus, for example, 7, and here you have 8 plus 8 plus 7 plus that's negative 6, so that's positive 6, that's positive 1, that's 7, that's 9, that's 10, that is 5, that is 2, that is 7, that is 8, that is 7, that is 6, that is 1, that is 7, that is 9, that is 10, and that is 5. And 2 plus 7 is equal to 9, 9 plus 8 is equal to, this is 9, this is 15, this is 7, this is 16, this is 15, this is 9, this is 15, this is 7, this is 16, and this is 15. And if you add all of these together, you'll get 24, and here you will get 7 plus 16 is equal to 23, and here you will get 24, here you will get 22, here you will get basically 16 plus 15 is 20, 31, 15 plus 16 is equal to 31, and then you will have 47, 47, here you will have 46, and here you have 31 of these numbers. Now 47 plus 46 plus 31 is equal to 13, 14, 1, and that's 8. 8 plus 3 is equal to 11, 12, 124. 124 divided by 20. That's 124 divided by 20. That is 124 divided by 20. 124 divided by 20 divided by 2, you get 62. You get 62 by 10. That's 6.2, I suppose. That is 6.2. And the answer is correct. So you can see that this is a tedious process. And, well, of course, this way you can get to some answer, meaning that the mean deviation about mean is 6.2. That means that on average, any data point could be at this distance, on average at this distance from the mean of the data. Okay, so that's some number which can be some sort of representation of the data. I don't know if they do it, I mean, if you're supposed to do it all the time like this, but it doesn't seem to be the right way to do it, because I think they must have come up with some other way of doing it. Or suppose that you have another example number 3. You want to find the mean deviation about median. Mean deviation about median for the following data. So the data that what you want to calculate is mean deviation about median. So now, in order to calculate the mean deviation about the median, so of course the formula for this, the formula that you can use is the mean deviation about the median is equal to 1 divided by n times sigma basically the absolute value of x of I minus basically the median, and then as I goes from 1 to n, for example. and so what that means is that first you need to find the median of your data. Now suppose that your data is 3, 9, 5, 3, 12, 10, 18, 4, 7, 19, and 21. So the median of your data is basically you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 data, basically observations. So since the number is an odd number, then basically the number that you're looking for, which is the median of your data, first of all you have to write your data in an ascending order, meaning that you have to write this as, for example, 3, 3. So these two are taken care of. Then you have 4 and 5. And you have 4 and 5. And then you have basically 7, 9, and 7, 9. And then you have 12, 10, and 21. 10, 12, and 21. So now your numbers have been written in an ascending order. So now that the numbers have been written in ascending order, what that means is that then 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It's not supposed to be equal to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So 10, 10, 12, 19, and 21. Because I forgot the 19. 19 and 21. So since you have 19 and 21, so you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So you have 3. Let me erase all of this and do it again. So you have 3 twice, which is 3 twice. And then you have 4 and 5, so 4 and 5. And then you have basically 7 and you have 7, and there is no 9 here. There is no 9 here, so you have 7, you have 10, 12, 18, 19, 21. 10, 12, 18. You have 18 over here. So then you will get basically 1, 2, 3, 4, 5, 6, 7, 8, 9. So you have 2 3s, then you have a 4 and a 5, and then you have a 7, and then after 7 you have 19, 21, 10, 18, and 12. 19, 21, 10, 18, and 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so let me do it over again. So to write the numbers in an ascending order, so you have 2 3s here. So 1 and 2 3s here. 3, 3. And then you have 4 and 5. So 4 and 5. 4, 5. and then you have a 9, you have 9, 10, you have a 7 as well, 7, 9, and 10. So 7, 9, and 10. You have 12, 19, 21, 18. So 12, 18, 19, 21. 12, 18, 19, and 21. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So now you have your data, your observations, and your n is equal to 11. That means that n is an odd number. That means that the number which is the median of your observations is basically n plus I suppose n plus is I suppose n plus, that means the observation that is the median of your data is basically, if you have, for example, let's say you have 3 numbers over here. So you have x, y, and z. So then this number over here is basically your n is equal to 3. So 3 divided by 2 plus 1. So that would be 4 divided by 2, which is equal to 2. So that is n plus 1 divided by 2. So n plus 1 divided by 2 term is basically is the median of your data. So now that your n is equal to 11, so that's 11 plus 1 divided by 2, which is equal to divide by 2, which is equal to the sixth observation. So 1, 2, 3, 4, 5, and 6. So that means that the median of your data, is 9. So then the mean deviation about the median is equal to 1 divided by 11, which is 1 divided by n, which is 1 divided by 11, times sigma of x of I minus m. So x of I minus n is basically all of these observations, the difference of all of these observations and the median. So then you can write this as 1 divided by 11 times, for example, the difference of all of these observations and your median. So the absolute value of, for example, 3 minus 9 plus the absolute value of 3 minus 9 plus the absolute value of 4 minus 9 plus the absolute value of 5 minus 9 plus the absolute value of 7 minus 9 plus the absolute value of 10 minus 9 plus the absolute value of 12 minus 9 plus the absolute value of 18 minus 9 plus the absolute value of 19 minus 9 plus the absolute value of 21 minus 9. And that is equal to 1 divided by 11 times, that's negative 6, which is equal to 6 plus again 6, that's a 5, that's a 4, that's a 2, that's a 10 minus 1 is equal to 1, that's a 3, that's a 9, that's a 10, and that is 21 minus 9 is equal to, let's say 21 minus 10 is equal to 11, so that's a 12. And then you have 1 divided by 11 times, this is a 12, this is a 9, this is a 3 plus 3 is equal to 6, 6 plus 9 is equal to 15, and then here you have a 22. So 12 plus 22 is 34, so you have a 34 here, and 9 plus 15 is equal to 24. which is equal to 58. So that's 58 elevenths. 58 elevenths, which is approximately 5.27. In the book, that the value is approximately, it has been taken as 5.27. Okay. So now that is the mean deviation for this data, the mean deviation above the median. Now this was all about the ungrouped. This was all about ungrouped data, meaning that your data was just some random data that you have collected from somewhere and you have not grouped your data. When you group your data, then there are some numbers that are representative of your data, and then you don't have to basically you don't have to take care of your data. You don't have to take care of each individual observation individually. Then you can basically, then you will, for example, get a number representative of some aspect of all of your observations. For example, suppose that you have 1,000 observations, 2,000 observations, and so on and so forth. Now, in that case, when you group your data, of course, grouping your data is done through some specific methods that we will, basically it comes through frequency and other different methods and techniques that we have talked about before. And then your data is basically called group data. So group data is then the kind of data that kind of has been, you can say that it's been treated in some way. And once your data is treated, then you have specific numbers representative of different aspects of your data, and then you can use those numbers in order to calculate, for example, the mean deviation about the median, or the mean deviation about the mean, and so on and so forth. Then you don't have to do all of this calculation by hand. Okay, so in the next video we will talk about the mean deviation for group data. We have discrete frequency distribution. We have mean deviation about mean. We have mean deviation about median. Then we have continuous frequency distribution. And there is a couple more things here to take care of. But before we do that, okay, so let's talk about that here as well. So the mean deviation for group data, basically when it comes to group data, mean deviation so when it comes to mean deviation for group data, let's see what we have over there. Okay, so what we have here is that we know that data can be grouped into two ways. Or data can be grouped in two ways, basically. Into two ways would not be a good sentence. So the two ways that you can group a data, that you can group a set of observations or data. So for grouping data, what you can do is basically, first of all, there is one way that is called discrete frequency distribution, which is called discrete frequency frequency distribution. And of course, when we will see some examples and you will know what is meant by discrete frequency distribution, I will hopefully be able to explain what that exactly means in terms of some example, and then we will move forward. And there is some other way called basically continuous frequency distribution. Continuous frequency distribution. So we have the discrete frequency distribution and continuous frequency distribution. Now when it comes to basically A, discrete frequency distribution, let's say that let the given data consist of n distinct values. Let the given data consist of n distinct values, namely x1, x2, x3, all the way up to x of n, occurring with frequencies f1, f2, all the way up to f of n. Occurring with frequencies f1, f2, f3, all the way up to f of n, respectively. Now I do understand what this means because I have done many examples before, but and there is no way to explain it unless you saw probably many examples. Now let's see how it goes, and then we will decide what to do. Now this data can be represented in the tabular form as below, and is called discrete frequency distribution. So this data can, if you basically represent this data in tabular form, it will be called basically in tabular form, it will be called discrete frequency distribution. Of course, I have, for example, these terms, discrete, for example, discrete frequency distribution. I have, for example, I might have forgotten such terms as discrete frequency distribution and so on and so forth, but I do understand what it means actually in terms of practical examples. So then basically you have, for example, your x as, for example, x1, x2, x3, all the way up to x of n, and you have your f in terms of f1, f2, f3, all the way up to f of n. So that's basically how you can represent your data. And if that is the case, then the mean deviation about mean, then the mean deviation about mean. So So as you can see, of course, it's not easy to explain this. I mean, let me go with the flow of the material here, and then if that's necessary, then we will include some other things here. Otherwise, it's not really easy to explain what it means. So first of all, we find the mean or x bar of the given data by using some formula. So what we want to find is the mean deviation about the mean. So that means that first we need to find the mean and then find the mean deviation about the mean, right? So first we find basically first we need to find the mean, which is x bar of the given data by using this formula. You know that your x bar is equal to sigma of xi f of I divided by sigma f of I. So what this means is that basically you need to calculate sigma x of I times f of I when I is equal to goes from 1 to n, and you need to divide this by sigma f of I as I goes from 1 to n, right? And that is 1 divided by n, 1 divided by capital N, sigma x of I times f of I as I goes from 1 to n. So what this means is that suppose that you have some observations, like for example 2, 3, 2, 5, 7, 5, 6, 8, 9, 8, 15 and 16. Right, in order to find the mean of your data here, you can use this formula. So each of these is called an x of I, and of course you can see that you can see that, for example, 2, how many times does 2 happen here? 1, 2 times. So 2 is the frequency related to 2. The frequency related to 2 is 2. So these are your observations. So the frequency related to 2, or f of I, and this is your x of I. So this is one observation, and this is the frequency related to that observation. So for example, the observation 2 happens 1 and 2 times here. So the frequency related to that is 2. And then you have, for example, another observation which is 3. So that the number of times that it happens is only once. So that's the frequency related to that. Then you have, for example, 5 over here. I'm just writing them in an ascending order. Then you have 5 over here, and 5 happens, for example, 2 times. And then you have, for example, 6 over here. So 6 happens, for example, once. 6 happens once. Then you have 7 over here. 7 happens once. And then you have 8 2 times. You have 8 twice. You have 9 once. You have 9 once. And you have 15 once and 16 once. You have 15 once. And you have 16 once. So now what happens is that, of course, if I were to find the if I were to find the mean of this, or the average of all of these observations, I would add all of them together, right? I would add all of these observations together, and then whatever I got as the sum, I would divide it by the sum by the number of these observations. So on the other hand, what I can do, and that would be a tedious kind of thing. So now what I can do is I can basically calculate sigma x of I, for example, here. Sigma x of I means all of these numbers added together, 2 plus 3 plus 5 plus 6 and so on and so forth. That would be, for example, 16, 16 plus 15, 16 plus 15 plus, I don't know, 24, 16. 24, 16. And that would be, for example, 11 plus 10 is equal to 21. 11 plus 10 is equal to 21. And then you have 4 plus 3 is equal to 7, so that's 71. So I call the sum of all of these numbers 71. But and of course you need to pay attention to the fact that if you add all of these numbers together, that would not, of course, be equal to 71, because there are numbers here that have been repeated. For example, this number has been repeated twice, this number has been repeated twice, and so on and so forth. So now the frequency of these numbers was basically, that's 3, 5, 6, 7, 9, 9 plus 3 is equal to 12. So that means that sigma f of I is equal to 12. And when I write sigma f of I, now that we are talking about it, let's talk about it properly. When I write sigma f of I, that means f of 1 plus f, as suppose that I is equal to 1 all the way up to n. That means f1 plus f2 plus f3 plus f4 plus all the way up to f of n. Right? So that's sigma f of I as I goes from 1 to n. And you can imagine that, for example, you can call this x of 1, x of 2, x of 3, x of 4, x of 5, 6, and all the way up to here, whatever that might be. So when you write sigma f of I as I is equal to 1, as I goes from 1 to n, that means that f1, f2, and all the way up to f of n, and that in this case is equal to 12. Now, of course, it makes sense that if I want to find the frequency of, if I want to find the average of these numbers, of course, what I need to do is that I need to basically add all of these numbers together and then divide by the number of those numbers. Now, what I can do here, in order to make things simpler, I can basically introduce or define another column here, call it x of I times f of I, meaning that this x of I times the number of times that it's been repeated. That means that 2 times 2 is equal to 4, 3 times 1 is equal to 3, 5 times 2 is equal to 10, and 6 times 1 is equal to 6, 7 times 1 is equal to 7. That is 16, that is 9, that is 15, and that is 16. So that is sigma, that is basically x of I times f of I. So now I have all of the numbers, that all of the observations times the number of times that they have happened, they have occurred, and I have basically calculated everything, multiplied everything, and I have written them all in here. Now what I can do, since this column is x of I times f of I can of course calculate sigma x of I times f of I as well. And if I were to calculate sigma x of I times f of I, as I, for example, goes from 1 to n, that would be x1, for example, f1, plus x2, f2, plus x3, f3, plus all the way up to x of n times f of n, which would be basically all of these numbers added together. So that's 17 plus 13, 17 plus 13, and here you have a 16 and 24, 16 and 24 and 16. So that's 10 and 20, 26, 2, that's 3, 4, 5, 7 and 9, that's 96. That is equal to 96. Now in order to find the basically, again, in order to find the mean of these numbers, what I need to do is that this is now essentially and officially the sum of all of these numbers together. The sum of all of these numbers together. So the sum of all of these numbers together happened to be 96. And basically the number of those numbers is basically sigma f of I. So then the average of all of those numbers that I have written up there, if I call it x bar, that's going to be equal to sigma f of I, sigma x of I f of I, sigma x of I f of I divided by sigma f of I. Sigma f of I. Of course, as I goes from 1 to I is equal to n, for example, with this condition. And so that would be 96 divided by 12, which is something about, I don't know, 45, 48, and 6, then 24, and 3, and that's an 8. So the average of these numbers is supposed to be 8. Now let's try to calculate this directly. So if I were to calculate this directly, I would write this as, so here you have basically 2 plus 3 is equal to 5, 5 plus 2 is equal to 7, 12, 19, 19 plus 5 is equal to 24, 30, 38, 47, 47, 47 plus 8 is equal to 57, 55, 65, 70, 80, 86, I suppose. So you have 86 divided by the number of these numbers, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Which gives you 7.1. It's supposed to be 8. Let me add the numbers together again. I might have made a mistake there. So 2 plus 3 plus 2 plus 5 plus 7 plus 5 plus 6 plus 8 plus 9 plus 8 plus 15 plus 16. 86. And the number of those numbers is the number of those numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So I think we've made a mistake over here. Now we might have made a mistake here. 4, 3, 10, 6, 7, 16, 9, 15, and 16. So let me add these numbers together. Let me see what I get. 4 plus 3 plus 10 plus 16 plus 7 plus 16. No, I made a mistake. 4 plus 3 plus 10 plus 6 plus 7 plus 16 plus 9 plus 15 plus 16. It's 86. This is 80. This is supposed to be 86. This is suppose the mistake was here. So then this is supposed to be 86 divided by 12, which is, well, 86 divided by 12, and that's basically, we got the same thing when we tried to calculate these numbers. So that's basically the frequency distribution table of a set of observations. Okay, so and so when we write here the sigma x of I f of I, what is meant by that is basically this thing over here. That is f x of I times f of I, and when you add all of them together, that becomes sigma f of I x of I f of I. And when we write sigma f of I as I goes from 1 to n, when you write sigma f of I as I goes from 1 to n, that means that basically, again, this is I is equal to 1 to n. And the I goes from 1 to n, that means that you add all of these numbers together. And that's the same thing as this is the total number of times that all of these basically occur, which they have called it n, right? This is in the denominator, they have called it n, and then they have written the sigma x of I f of I as I is equal to, as I goes from 1 to n of x of I f of I, and that's basically why the x bar is equal to this thing over here. So hope that you have understood this. Otherwise, you should go back to the book and learn this in terms of some examples, some practical examples. For example, there is a bunch of examples over there. There is a bunch of exercises over there that you can do, and then that way you will be. And of course, if you didn't get it, if you didn't understand it using my explanation here, that doesn't mean that you cannot understand it. That just means that you should go back and read it, because it's not something that you can learn in 20 minutes or so. It's something that you need to spend time with, because when the concept is new to you, you always have to spend some time with the concept in order to absorb it and digest it. Okay, so now let's move on with this formula. Let's move on with the formula. Let me erase all of these things. And of course, the data that I wrote here, for example, all of these numbers, that could be the height of, like, I don't know, a bunch of people, that could be the ages of a bunch of people, that could be anything. But essentially, it's a number of observations, and then you want to basically find some way in order to represent that in a tabular way. Now, I will continue the rest of this discussion in the next video.